going to be talking about identifying using complex numbers, and this is day 3. Now, this is an extension and enrichment, so you won't see this in your book, so it will be a handout. But we're talking about complex conjugates. But before we can talk about complex conjugates, we have to know what a regular conjugate is. So if we have something like x plus 5, the conjugate of that is x minus 5. And if we were to FOIL this out, we get x squared plus 5x minus 25. And if you notice, the middle numbers cancel each other out, and we get x squared minus 25. So the x value cancels out. It's no longer there. So a complex conjugate is the same concept. Instead of the x value that gets canceled out, it is the I value that gets canceled out, and you're going to see why in a minute. So let's talk about what the complex conjugate is of each of these. For 5i, it's going to be a negative 5i. For negative 5i, it'll be 5i. For 6 plus 2i, it's going to be 6 minus 2i. And 6 minus 2i will be 6 plus 2i. For number 5, negative 6 plus 2i, we just changed the middle, so it's going to be a negative 6 minus 2i. And for negative 6 minus 2i, it is a negative 6 plus 2i. Okay, so that is the complex conjugate of each of these. And we're going to use them now to divide. When I divide a complex number, we have to rationalize the denominator, meaning we cannot have an imaginary number in the denominator. So what we do is we multiply by its conjugate to get rid of the imaginary number. So the conjugate of 2i is a negative 2i. Okay, and then we distribute, and we get a negative 24i minus 6, because 3 times 2, negative 3 times negative 2 is a positive 6, and I squared is a negative 1, so we change it to a negative 6 over 4. Okay, so now what we're going to do is we have to write this in standard form, and we're going to have to split this apart. So let's split this as a negative 24i over 4 minus 6/4. Well, in standard form, the real number does have to go first, and we're going to simplify our fraction. So we have 3 halves, negative 3 halves, minus 6i. And that is now in standard form and simplified. So let's look at this next one. We're going to multiply by the conjugate, which is 7 minus 4i. And we have to FOIL. So that's going to be a 21 plus 35i minus 12i plus 20. All over, and since we already know that the middle values are going to cancel out, let's just multiply the first and the last. So that's going to be a 49 plus 16. Okay, so let's combine our like terms. We have a 41 plus a 23i all over 65. Let's split this apart. We get 41 over 65 plus 23 over 65, and we like to put the I at the very end. Those cannot be simplified, so it just stays like that. Let's see 2 more examples of these. Okay, we're going to multiply by the complex conjugate, so we do 1 plus 4i and 1 plus 4i. FOIL again. So we get 7 plus 5i plus 28i minus 20. Next one is going to be 1 plus 16. So that's going to give us negative 13 plus 33i over, oh, that's a 16, 17. Now let's split this apart, and we have a negative 13 17ths plus 33 over 17i. There we go. Let's do our last example. We have the conjugate, which is negative 3 plus 2i, FOIL this out. So we get negative 15 minus 6i plus 10i minus 4 all over 9 plus 4. Okay, so what we're going to have here is a negative 19 plus 4i all over 13, which gives us a negative 19 thirteenths plus 4 over 13. So that's using our complex conjugate to rationalize the denominator of a fraction. Let's move on to graphing, okay? Now, when we have a complex number, we can't graph on the regular xy plane because we have an imaginary number, but we do have a complex plane. And this is our complex plane. And our complex plane, on the horizontal axis, we have real numbers, and on the vertical axis, we have imaginary numbers. And instead of having an x and a y, we're going to have a real, comma, imaginary. So the value of our real number here is 2, and the leading coefficient of our imaginary number is 3. So that's graphed as 2, 3. Now let's graph its complex conjugate, which is 2 minus 3i, so that's going to be 2 comma negative 3. Now if we look at this, the graph of the complex number and its conjugate, if we notice carefully, it is reflected over the real number axis. Let's see if that's true for number 2. The complex conjugate of this one is negative 1 plus 3i, so our 2 points are going to be negative 1, negative 3, and negative 1, 3. Let's see what that looks like. Negative 1, negative 3. And negative 1, 3. And that's true. It is reflected over the real number axis. Now let's take a look at 2 more examples. This one, it just has an imaginary number. So the complex conjugate of this one is negative 5i. So since we don't have a real number, this is going to be 0, comma 5, and 0, comma negative 5. So we have our real number axis and our imaginary number. So we're going to go 0, 5, and negative 5. And once again, it's reflected over the real number axis. Now for number 2, since we just have a real number, we do not have a complex conjugate for this. So all we're going to do is graph negative 2, 0. And that's it.